Okay, so I want to get another show of hands. Who's been using SolidWorks less than 1 year? Almost the whole room. Less than 5 years. A couple more. Anybody more than 5? Okay, so this is drawings basics. Now, I got to be honest with you. This is not an easy presentation to craft. When you're thinking about content, it's got a lot to do with your perspective. And when you've been in the product for a long time, you sort of lose track of the basics, the things that are everyday items. You take them for granted, you don't think about them because they're second nature to you. So this will be an interesting presentation for everybody. We're going to do some question and answer at the end too, so I can hopefully fill in some of the blanks that we did not cover. So again, my name is Darin, and I'm from Decide Solutions. Just a little side note here. Decide has been a SolidWorks reseller from day one. We were one of the Charter 12 that started back in 1995 with SolidWorks, so we've been around for quite a while. Now, in the last 3 months, we have purchased or completed the purchase of, it's been going on for a year, but another reseller called Digital Dimensions, who's also one of the Charter resellers with SolidWorks. DDI is out of Arizona and California, and what that's effectively done for the Decide Solutions customer base is basically extended our East Coast support time. So when the phone call rings, the phones ring in our offices, but we now have coverage from 8 a.m. to 8 p.m. for anybody in the East Coast, and then 5 a.m. to 5 p.m. for the West Coast users. So I just want to throw that out there for any of you that are my customers. I've been doing this for just shy of 20 years. Coming up next month will be my 20-year anniversary. We had about 3,000 users in the world when I started, and now we've got about 3.6 million. So it's been a pretty good ride, and you guys are to thank for that. So I do appreciate that. My job doesn't exist if it isn't for you. So the customers are our lifeblood. So thank you. I've got a lot of accolades over the years. Lately, I've been called a treehouse master. Spent the last 2 months building this thing. Now, that's a 12 by 12 treehouse. It's 15 feet in the air. It's got all the nice brackets and things that you see on the shows if you've ever watched some of those things. Enough support to put about 22,000 pounds of wood in the air if I needed to, which is way over designed. But in my real life, everything I do starts in SolidWorks. So I've done multiple decks and remodels and garages and basements and bathrooms and a couple of things here. But this is using weldments functionality. So not what we're talking about today. But when I get a chance to vet something out, form, fit, and function is always tested in the CAD system. Doesn't matter what it is. I'll build it up real quick. I'll get the framework, if nothing else, and use the CAD system and trust it very much. So do that kind of stuff as you move forward. It's a good reason to have stick time and to be able to use the software. So does anybody recognize these kind of things? These are napkin sketches. This is the poster child for an idea that came up when you least expect it. Now, napkin sketches are generally how we try to convey things. Anybody has not had drafting in high school, college, junior high, anywhere? You all had an annual draft. Did you do any drafting board work? College? Okay. I'm glad that they still teach you, because if you don't know the concepts, you don't know how to do these things, first of all, you won't appreciate how the updates in the CAD system work when you don't have to redraw from scratch. You still have to know the basics of how projected views work, what annotations are proper, how GDT works, and even that's getting a little bit higher with a lot of what people do these days. This is what we're trying to produce. That's what SolidWorks is capable of, is the wheelhouse of the software. You make your parts and assemblies, drop them onto a drawing. The drawing virtually makes itself. Now, a lot of people think that this is a lot of work. So hopefully, for those of you who are somewhat new to the software, I'll give you the basic workflow that you would use to go ahead and create drawings. And basically the stuff that no matter who you are, you should be able to create and put on your drawings. So we're going to break this up into 5 little segments here. Everything we do starts with a 3D part. So no matter what it is, the geometry is what drives your drawing. Now, if you want to do 2D drawing or drafting in SolidWorks, sure, you could do that, but it's definitely not the tool of choice for things like that. Once your parts and assemblies are there, which we'll cover in a later step, the drawing views virtually make themselves. Now, I always have a fear of showing presentations like this because I feel like everything I'm going to show you is something everybody knows. But honestly, when I get a chance to watch somebody present, whether it's the surfacing that Sean's doing over there with admin or up in the top there, I always learn something, no matter what it is or who's showing the product. So there's always a chance to learn something. Once we do our drawing views, you have to annotate them. Got to have your dimensions. Sometimes we'll have GD&T depending on what level you need to communicate with the user. And then of course, assemblies and parts are both used for this. But when we talk about assemblies, now we're talking bill of materials, ballooning, those kinds of basic things. So we'll cover that a little bit as well. And then in the end, change assimilation is a really huge part of our software. The only thing constant, frankly, about design is change. When you're making something, the only virtual certainty is that it will have a change at some point, most likely dozens. So we want to show you how the change update takes place and just give you the confidence, if you're not really adept with SolidWorks, to understand the files and how they actually talk to each other and the updates roll through. So these are the things we're going to try and hit today. So some of these will take just a couple of minutes, others we'll expound upon. And if we get to the end of this data here, I got a few other things just to fill the time, but we'll see how we are with questions and answers. But it all starts with creating the parts. So we're going to make parts. I'm not going to show you that part of it, but I will show you what we're starting with, and then we'll get right into the drawing creation stuff. So let's get started with a 3D part. So kind of an awkward question, I guess. Anybody not made a 3D part yet? Okay, I'm glad. A couple haven't. So you'll be a little new to the software at this point, but we'll kind of go past this just a little bit as we go. But here we are in SolidWorks 2017. Now, when you're talking about 3D parts, the basics is that you're starting files like you would in a word processor, you're opening up a document, and then you're creating geometry. And on that geometry, you're going to draw shapes. So sketches with circles, lines, arcs, polygons, whatever that might be. When you draw these shapes, they're just basic sketches, but those sketches have dimensions. So as we go ahead and start putting dimensions on edges, whatever you type in as the value is what that's going to update to. So it's a very easy thing. But these are the dimensions that are generally drawn upon when we're making 2D drawings. So I've got a couple of sketch dimensions, we hit extrude, and bam, there you go, you've got a solid. Now the dimensions that are used for sketches and features, here's the 2D sketches in black. Any extrude or other feature dimensions like draft and other things are going to show up as blue. And that's really the color coding that we use at this level of things. But as you start to build, what you end up with is a bigger picture of what this part's going to look like. Now I'm going to roll back in SolidWorks, something you might not be used to over here, but there's this tiny bar at the bottom of your feature tree. And you can roll back and step through feature by feature to see exactly how this part was built. So I can see that we had a cut, we've added some fillets to the inside of the cut, there's a little chamfer around those edges, and then a boss added to the bottom. A little shaft undercut on that, got a little revolve at the bottom that's going to give us a snap ring groove there. And then we've got a couple of other features there to tidy this thing up. But every one of those steps has feature dimensions available to it. Now, one of the things about these dimensions is that generally, part like this, I could probably get away with it pretty easily. But a lot of times these dimensions aren't the types of dimensions that you'd use in a 2D drawing. They are there for feature change. They are there for predictable and controllable parametrics, which means as you change something, your design intent is going to drive how it updates. So generally, because features are built sort of on an island, they give you a bigger picture here. But when it comes down to it, what we're really talking about is individual features here and there. So as we have one feature here is dimensioned as if nothing else exists, and then other things get added to it. And in some cases, that design intent will work, and in other cases, again, it is just to control the design intent of that feature. So as we start with a part file here, this is really the underpinnings of making a drawing. So to do that, we're just going to make a brand new file. Now, in a Windows product here, you'd look for the little white dog-eared piece of paper. Think of Microsoft Office, Word, Excel, whatever you want to do there. But underneath this pull-down, there's two different choices here. You can either say you want a new file, which will generally choose either part, assembly, or drawing. This is just opening up a blank file regardless of how you cover that. When you have a document open, part or assembly, when you hit that new file pull-down, you're going to also see make drawing from part or assembly. And that's really the workflow that you want to do there. What this will do is not only start a new drawing, but it will also automatically populate the view palette with the document that we see here currently. Now, one of the things you might see here is that I've got a bunch of different tabs. These tabs are folders on your network, in my case, folders on my hard drive, but they contain drawing templates. Now, I've got a lot of different ones here. Generally, they're different sizes. Some of them I've created wide format, so C size height, but 3 to 4 times the width of those kinds of things. Each of these is a starting point, and it's a starting point that has preset things like standards, font heights, dimensional tolerances, other things that I might not want to have to start and set every single time I make a new document. When you just have an initial installation of SolidWorks, you generally don't have a trove of these built up yet, so you'll just have this one tab called Templates. Now, using this is going to give you an opportunity to use what SolidWorks provides. Now, SolidWorks provides every ANSI and ISO size drawing template that you can imagine. So you're going to have your A, B, C, D, and E sizes for ANSI, but then you get the European sizes of just A0, 1, 2, 3, and 4. Each of those, again, being available because we're sold in 85 countries and 14 languages. So we're pretty much covering every geography out there. When you start one of these, say we'll grab a C-size landscape. This is a generic file that you'll get from SolidWorks. It has a title block, so down here in the corner, you're going to have some details of text. There's also some preset properties down there as well. So if I click off of this for a second, what you'll notice right down there is that I've got a name that's already appeared here. There's a scale value, there's a sheet number. These are associative things that are actually going to go ahead and change dynamically. Now, keep an eye on that in just a second here, and I'm going to go ahead and start making drawing views. Whenever you start a brand new drawing, whether you're a seasoned user or a novice, this thing called the view palette is actually quite helpful. And just so we don't get all kinds of things flying around here, let me just pin that in place so all my windows sit nice and stationary. What it does is it shows you all the standard views available. Now, United States, generally you're going to do third angle projection, but if you're dealing with European clients or customers, first angle is something you can also set these to. You do not want to set it to first angle and then make parts here. We've had companies that accidentally install it with an ISO installation instead of an ANSI installation, and they end up making parts that are completely mirrored of what they're supposed to be because of projection rules. So generally, if you install it in a United States computer, you're going to get a third angle projection. One of the things I like to do, though, is make sure that this button is checked. Now, it's not necessarily checked by default on a new installation, but once you check it, it stays persistent. And it's called Auto Start Projection View. When you're given all these different views to choose from, including some other named and other positional views that are there, you really just want to grab a view and drag it out to the location you'd like it to be placed. So with Auto Start Projection View selected, once you drop this first view in place, what's going to happen is it's going to automatically project just based on where your cursor is. Now, it's essentially throwing a top, right, a front, or an isometric view depending on where that cursor is. But the key here is that you just want to click where the view happens to be. So I'm going to click over to the right. I'm going to also click a bottom view here. And I'm also going to go up and to the right here for an isometric view. But I don't want the view up there clearly. So before I actually place that view, if you hold down the Control key, it actually breaks the alignment. So now I don't have to drop it, exit the tool, and drag that view over into a position. It's pre-selection or pre-dropping. So just hold down Control and click it where you want it. And then everything is going to have either static projection or, again, be broken projection with that Control key held. So that'll be your first little tip there. What basically happens with this, though, is it lays out all of those standard views. Now, that being said, when you take a look at the view palette now, what it'll actually do is it will show you views that are on the view palette that happen to already get used on the drawing. So you see the front and the right and the bottom and the ISO views have these icons next to them. And those are indicative of the fact that if you looked at this, there's already a drawing view out there of that position. Now, in years past, we also used to eliminate those from the view palette, but that really turned out to be something where if somebody wanted a second front view, it wasn't quite good for workflow. So we leave it there and just indicate it that's on the screen. But what's happened here is we've also got a parent-child relationship created by the way I projected these. I placed this view first, which if we move it around, it's going to keep the projection of all the other views that are there. But this view is also the parent to these other views, not just positionally, but also display style-wise. So if I take this view and select it, and we're selecting inside the view, which is this border, but not on the part. Got to be very clear where you're picking because whatever you select is what you're actioning on. So if I select inside this view but not on the part, I have the capabilities of switching it over to, say, hidden lines visible, which you now see every single view do. Or if I go ahead and take that view and switch it over to shaded, you'll see all of the child views falling in line with this display style. So I generally start my drawings here with the hidden lines removed, just the best, most common way that I'm going to display these. And then when I need to, maybe I'll go ahead and take a file like this top view here or this right view, and we'll just make that one a hidden line shown, or the isometric view again inside the view but not on the part. We'll show that one as a shaded. So this is all pretty typical stuff. Now when you're moving these views around, you'll notice that these views keep their projection. You can break the alignment, although I'd never recommend doing that, at least in most cases for the standard. But if you like the distance that these views are from each other and you still want to move them, holding down the Shift key in this case actually moves them, but it keeps the current spacing that you have. So if your drawings are sitting in a really nice position and you like to keep them right about there, holding Shift while you drag a view around is going to make them all keep that location. So another little tip on the side of that one. So basically that's it. You're just laying out the drawing, and placing out the views as necessary for our particular purposes here. Now the template itself also did some other little magical things. If you notice the title block down here, we've got some other data that's now showing. So what you now see is this value here called rod end. We've got an ANSI 3440 or 4340 steel annealed. These are properties, and these properties are part of the part file itself. So right now you see this one that says rod end. Well, if I go back to the part file, for example, this is one of the part properties that are placed either through data management system or just through simply saying file and down to properties. Now properties are important because these are things where if I set them here, I can use them for a lot of things. I can fill out title blocks and bills of materials. We can search based on these, and they will also auto-populate data cards in a PDM system. But when we get into these different things here where we've got values, whether it's a description value, whether it's a configuration specific, right here we see rod end. If I switch that over in the part file and call that rod end demo, for example, what happens is associativity. We go back over to the 2D drawing and you'll notice that that value has automatically changed. If you have to manually type something in, that's something you have to keep track of. This is what we call an associative value. Whenever I change it in the one spot, it's going to automatically trickle down and update wherever it's necessary. So this is one of the kind of extra credit things we'll do at the end if we get the time. But I want to make sure that you know how to set up some of those properties in the end, no matter what we do. So when we're looking at what we're dealing with then, the 3D part drives all this information. It's the parent for the drawing. If you send the drawing to somebody, you need to send the part and or assemblies also. So that's a very basic thing for a lot of novice users, is you'll end up sending somebody an assembly or you'll send them a drawing and they'll try to open it and they'll have no choice but to open it read-only. Files that we have are dependent. So the part files are the main files, assemblies and drawings depend on the part files. So make sure that you have all those sent whenever a file is being transported from one person to another. Sketch and feature dimensions can be used in this circumstance, and I want to show you that here when we do the annotations. There's also something that we have here called named views. Now, named views is something I'm going to bounce back and show you real quick. When you're looking at the views that we laid out here, these are standard projected views. They always start from the front and they're just orthogonal projections. But if you're back in the part file or the assembly file and you find a really strategic view, maybe for conveying some sort of information, what you can do there is just simply go ahead and orient that view and then hit your space bar. What that's going to do is bring up a tool here called the view orientation box. This allows you to actually go ahead and update views to different orientations, but also save new views. So if I like this view, I'm just going to go ahead and call this a named view. So we'll just wait for that to pop up here and we'll call that one cool view. Sorry, my screen capture is slowing me down a little bit here. Maybe, we'll see. All right, we'll come back to that in a second. Properties, though, drive these fields in the drawing. That's something I like to show. Now, who does use properties currently? Anybody pulling that off? Who would like to use properties in their drawings? This is something I feel is a necessary thing. We'll try and drive it forward so we can get to that particular point. The views themselves, though, are very simple. We drag those out, we lay them out. I'll show you the named view here in just a second. But the main thing, though, is that the drawing takes care of itself. Parts assemblies are going to be the shape that we place on each of those. And then they all have relationships. But mainly, this is the point that you want to get to. Now, on this drawing, I've got a few other views, which I'm going to go ahead and lay out for you as well. The section view down here in the bottom, absolutely essential. And then detailed views, probably the two most essential ones. There's auxiliary views, there's projected views, and other things like that. But essentially where we're sitting right now, we're basically looking at the main underpinnings of what a drawing needs to be. All right, so I'm getting a little bit of an issue here. Give me 1 second. Let's see what we got. Ah, that's fine. All right, maybe not. All right, give me 2 seconds. I'm going to kill this one and we will come back to it. Oh, the one thing I hate doing is I loaded up that thing over there for the projector that they've got, and I never like to do those things right ahead of a presentation because it messes with your resolutions. All right, we'll come right back to that. So when we're putting in our 2D drawing views, the names of the views that are on the file there are also a fairly important type of a thing. So what you're going to see on the drawing that I've got up here right now are just the basic views that we started out with. However, when you save a part with those named views, you can draw upon those. So over here we have the one that I've saved here at an odd angle. It's just an orientation that, again, maybe it was advantageous, but wasn't a specific projection off of any of the other edges that happen to be here. When it comes to creating additional views here, though, projected views are one of the most common that you're going to run into. Now, you can use edges in a view to go ahead and create those projections. You can go ahead and draw lines to create any of those projections, or you can just simply go ahead and use some of the common projection tools you have in your View Layout tab. Now, a couple different ways to do this would be to choose a section or a detailed type of a view. Now, when you grab the section view, what this is going to do is walk you through a bit of a wizard. Over on the left-hand side here, we've got different ways of positioning a section line. Now, when I'm in the graphics area, you can see right now I have one that's got an angle to it, and this is an aligned section. If I switch this over to a vertical, you'll be able to see the vertical line, and it's wherever your view is closest to when it comes to your cursor. However, when you're out there, you can also switch those values just by hitting the tab key. So by tabbing through each of those, you'll see an aligned section, you'll see a vertical, then you'll go ahead and actually see it switch over to, we don't want to start that one. We'll go ahead and see this one switch over to a horizontal. But these are going to be full sections. It's whatever view you're closest to, though, is the one that's going to be generated. Now, when you get close to the view, you can snap to circular geometry just by hovering over the edge of the circle. You don't have to find that center point. Just go ahead and hover over the center of it, the circle of it, and it will snap to the center of any hole that you want to go ahead and cut through. Now, once we go ahead and select that, this is another little extra credit thing we'll do if we've got some time here, but these are the ways to make notches. Notches are something where if you had, say, a plate with a bunch of holes, you might want to cut here, jump down, cut a hole, jump up here, cut through another hole. Sorry about the hand puppets, but basically you're trying to zigzag through a series of holes that might not fall in line with each other. Now you can do these on round parts with arcs, you can do simple notches, or you can just zigzag through it pretty much just through selections. When you just want to do a single center line, we'll go ahead and say OK to that, and then that will generate our section immediately. Now the section itself gets generated based on a couple of different things. The section cut itself obviously is going to give you the geometry and the capping of where the material is, but what you're also going to see here is a crosshatch, and that's physically based on the material that you've chosen for your part. Now in any circumstance here, the material is going to have the hatch, a color, some sort of real view graphics attached to it, and a mass property. And all of those things are very important when it comes to testing the weight of a part once it's done and doing some simulation. But here on the drawing, it's going to go ahead and give you the proper hatching immediately. Now I'm a big fan of taking views like section views, turning these into shaded views. Really resolves a lot of ambiguity, especially when it's cutting through an assembly. When you've got a lot of parts that are the same material, a lot of crosshatches match up and everything melds together and it's very difficult to see. So sectioning through any type of a part or an assembly with the shaded is a much easier way to deal with things. For tiny detail that you need to go ahead and clear up or show, detail views are the best way for that. By default, they're going to expand the size of whatever view you draw them on by 2. You can expand that to whatever you want. That just happens to be the default installation value. Now with this, it puts you into a circle sketch tool, but feel free to sketch any shape that you want that bounds a region. So it could be a rectangle, a spline, make a little kidney shape, a circle is our default, but any shape that really works. If we want to go ahead and make a bigger view of this snap ring cutout, I'm just going to draw a circle in an area around there. Now what I like to do is I like to make sure that the center point of this circle snaps onto something. The reason being is not so that the circle moves if the drawing view gets moved, but if this part gets longer, say this shaft right here goes from 40 to 60, where I've snapped the center of this circle is going to be where that circle stays. So if the shaft moves over 2 inches, this is going to go ahead and move over with it. It's a simple thing to do. I don't really have to be very specific. There's a lot of midpoints and endpoints there. Just grab one that's good and then draw a circle that bounds a region. Now once we do that, you'll notice that detail view is going to be twice the size and attached to your cursor. Just go ahead and select anywhere in the background and that will create the detail view of that size. Now associativity is what we're striving for with everything here. When you do something manually, you almost have to assume that everything is manual and therefore would have to be checked if a change is made. But when things are associative, you don't have to make sure that the change is made in many places. You make it in one spot and it will roll through the rest of the part. Simple example is something like this detailed circle. If I pick and drag the detailed circle to make it larger, you see that that view keeps its associativity there. It's going to get bigger. Go ahead and grab that E and drag it to a better spot and really just make it a much more visually appealing type of a thing. But in any event, if you want to go ahead and click on the scale value that you have down here in the note, maybe go ahead and change some of this stuff here, or even go over into the view itself and change it over into the property manager. All of these values are fully associative. So if I want to go ahead and make this thing even larger, I'm just going to go ahead and in this case, we'll call it user modified. We're going to call this one 3 to 1 or 4 to 1. So it doesn't really matter how you take care of that. The associativity rolls through with the size of the view, the note that's underneath it, everything cascades right through the drawing. So that's a pretty important part of getting these updates to happen properly. Didn't really want that view, but we'll go ahead and get rid of that one. Okay, looks a little bit nicer in that respect. One thing else I'd like to show here is a little bit about updating. Now, many of you have probably tried this, but if you've never made a 2D drawing out of this yet, you might not be aware of this functionality. I'm going to take this side view here just for effect, and we'll go ahead and show that one as a hidden lines removed or hidden lines visible. And you'll see even in the section view here, this kind of a change that's going to take place. Now, I'm going to tile my windows for a second. I'm going to tile them by having my part file open at the same time, and then just being able to see both windows side by side. This isn't anything specific to drawings, it's just a Windows functionality, but you'll find this under the window pull-down menu at the top, and there's tile horizontally and vertically. Now, I like to use this a ton, so I've placed a hotkey on there of just the H and the V button.
All I have to do is just tap on V or tap on H, and I can go ahead and tile as many windows as I have maximized simultaneously. So it's a pretty pleasant way to deal with that. What I want to show you though here is the associativity. You go back to your part file and you realize that you've missed something. Go ahead and modify it, make a change, doesn't matter what it is. Here I've got a tap tool that I would generate if I had more time from scratch, but I'm just going to unsuppress it. And what you're going to notice is that in the bottom of this part where we no longer have a tap, we're going to see that tap show up, but then over on the 2D drawing, it just happens there automatically. So changes made to the part will roll through to the drawing and the assembly immediately. If I go ahead and take this part file here and I want to change its length for whatever reason, I can do that in the part file, and what will happen is the drawing will dynamically update. There's no worry about that. And that is one of the reasons why the part is so important to the drawing and the assemblies, is because the part is the main part of this file. Now, to expound upon that even more, when you're dealing with a part versus an assembly or a drawing, the file sizes will kind of back up what I'm saying about those. If you look at a part like this, let's just call this a 300K file. The drawing might only be about 50K in size, and that's because it contains the display data, the dimensions, bills of materials. But other than that, it's looking at the part file for the rest of its definition. It's just the graphics that it's really holding inside. So those are the kind of things that you're going to see from changing parts to changing the drawing itself. Now, the main thing, like I mentioned, that we want to get to are these things here, the annotations. And this is where you have to make some decisions. When you build the part, the general decision is are the dimensions that I've used to build the part the ones I would also use to manufacture it? And again, on a small part like this, I might be able to get away with something like that. But on a larger part, generally what's going to happen is the dimensions are going to stack up in such a way that they won't make sense. So at this point, I've got two choices, and I'm going to use both of these choices. One is to bring the dimensions in from the part itself. Now, this is found under the tab called Annotation. And the main thing we're going to talk about here is something called model items. The reason we call it model items is because these are things that we're bringing in from the 3D part or assembly and populating the 2D drawing appropriately. So for example here, dimensions is really the poster child for this kind of a thing. We say what we want. Do we want to specifically select a view? Do you want to select on the part and select a feature? Or in my case, I'm going to bring in all of the dimensions for the entire model. Now, it isn't just dimensions that we can pull in. You can pull in things like this happens to be a hole pattern numbers, so the quantities and spacings are going to show up there. Down here we have surface finish marks, GDT Datums, caterpillars for weldments. All these little details you can place in your 3D part files and have it automatically populate your 2D drawing. So if I wanted to throw a datum on a face in 3D and I want to throw a surface finish mark on there, it'll put it in the right spot on the 2D drawing. Now, the other thing that I do on this one, and we're just going to stick with dimensions in this particular case, but as I go to the bottom here, there's a magic checkbox, and this thing says use dimension placement in Sketch. Turn that off. When you use dimension placement in Sketch, think of the sketch that you've drawn in the 3D part, and where you clicked the dimensions, where you place them is exactly where it will place them on the drawing. So I guess if you're a little bit OCD like me and you place them nicely everywhere because it drives you insane if you don't, then you'll be okay. But if you just placed all your dimensions and kind of quickly gone through there, turning this off is going to make auto placement happen here, not the exact placement that you placed them on the 3D file. So when I say OK to this, it will start at the detail view, go to the section view, and then start rolling out to the main views and start adding details. So we'll say OK to that, and then we'll sit back and watch that happen. So when you've got a section view there, generally the idea is that because the section exists, you're conveying to the software that you want to show a lot more detail in that area. And that's why it focuses dimensions on that particular view. Now, if you don't care for that, getting the primary dimensions, a couple of ways we can deal with this is first, not having that view up there when I do the primary import of dimensions. It will go with the views that exist currently. But what you can also do very easily is grab dimensions, either one at a time or through window selections. And I like to go ahead and window select a couple different ways. Left to right versus right to left will be a crossing window versus an inside window. And you can move or copy these dimensions from one view to another. So if I've got dimensions on my section and I'd really like them up there on the front view, moving them is the Shift button. By holding Shift, I can go ahead and grab these dimensions, drag them from one view to another. You'll notice my little no smoking symbol there turns into an OK symbol when I'm inside the drawing view. If I go ahead and drop them there, they will auto-populate onto this view. Now again, these are dimensions that I brought in from the part file. So these are associative values. I can double click and change these just like a sketch dimension or a feature dimension, and it will change everything here and everything in the 3D file as well. A couple of other things that happen with this is that shift is a move. Now, if you want to go ahead and have dimensions that are associative and double-click changeable in multiple views, then what you're going to do is use a control key instead, control being a Windows universal copy. So if I got a dimension over here that I'd also like to have in this side view, I might hold down my control key and pick and drag that dimension over. And again, control is a copy. 28 is still over here, and 28 is also over here, both of those associative editable dimensions. Now, this looks like I'm making a bit of a mess of this, right? These dimensions are in place and they're kind of stacked on each other. Some of them I don't need. This 2-inch or 2 millimeter, this 45 degree, those are the dimensions that come through for a chamfer. It's not the best dimension ever. What you might notice is that if you go up to your annotation tools, and I don't have it up here by default, but typically I would have it up there, is there's actual command for a chamfer dimension. There's a physical specific command for this. So instead of having a dimension of a length and an angle as two separate dimensions, a chamfer dimension allows you to actually pick on that edge, and what that will do is allow you to then put in a combined dimension. Now this is a dimension I have just added, which means if I double click it, the only thing I can do to it is change its properties. These other dimensions here, however, are quite different from that. If I want to go ahead and take this dimension here, for example, and double click it, now I can change that to anything I want. And when I rebuild it, you'll see that my entire drawing updates as a result of that. Okay, so the ones you bring in from the model are changeable dimensions associative to the part. Ones that I've added to the part, however, are not driving dimensions, but they will react to the model change. Now we'll talk about that in just a second. But one of the things that I see a lot from a novice user is trouble laying dimensions out, putting them where they really matter, or just in a place that really just looks pleasant to the layout. So I'm going to throw a bunch of dimensions over here on the side and just kind of screw this up a little bit in an effort to really make a bit of a mess with a typical type of dimensioning layout that you might end up seeing. So let me just move a few other dimensions around. We'll start to get these a little bit screwed up. That looks pretty good. This is probably something that you're more used to seeing when you're starting off a project. I've got a lot of lines, they're kind of ugly, things just don't look quite right. So a couple of things that we can do with this, first of all, just drag dimensions around and you'll be able to change things like the position of that dimension. So dimension to the inside, arrow to the inside, really depends on just what your standards are set up for. But a couple of little drags will allow you to make some changes. Clicking on the handles that show up on any arrow will enable you to go ahead and switch the directions of those arrows. And that works for everything. Anything that's a linear dimension, when you pick on it, you're going to see handles on the arrows that will allow you to quickly go ahead and move those arrows around. If a dimension is between the leaders, it will auto center by default. That can be turned off. But if it's outside the leaders, generally you're going to go ahead and get a linear dimension, or if it's a vertical dimension like this, you'll get a dimension break. And those two with handles are modifiable. Now again, generally what happens is you'll get dimensions that are sort of a mess and on top of each other. And there's a bit of magic to this that not every SolidWorks user is aware of. Whenever you select dimensions, there's this thing that pops up here next to your cursor. You see this little box? Does everybody pretty much ignore that? Or do you guys use it? Who does use it? Okay, I'm gonna ask that question again next user group and we'll see if that's changed. This box will pop up. Hover over it. All kinds of magical things pop up. Now, a couple of the magical things that I use quite often, I'll show you on single dimensions. But here is a group of dimensions. The bottom row has a button here. And the button itself is called Auto Arrange. By picking 3 dimensions and clicking Auto Arrange, it automatically puts them in a place where they're going to look good. It will automatically space and orient each one of those dimensions. I can go ahead and take any part that I want, any view that I want, and I'm going to drop all kinds of dimensions all over top of each other. And just by window selecting all of those dimensions, clicking on this box and hitting Auto Arrange, it's going to automatically make my drawing view look beautiful. Scary, isn't it? It's quite scary. This value is something that's set in this drawing document, this template. Now, a lot of the values of the settings that we have for these kinds of things are set in the properties. Now, generally, you'd find those under the Tools pull-down menu, and way, way, way down to the bottom of this, depending on the resolution you're running your computer, is where we get to options. It's a little gear icon. But the gear icon also lives right here at the top of your interface as well, so use that one instead. When we click on that button, what you now have here are system options and then document properties. Now this again is kind of 101 with some of our classes, but document properties are the values that live with this file. So if I save it and send it to somebody, everything that's set in this tab will also go along with it. That's going to be things like the standard that we're adhering to with this. but also anything that I want to go ahead and modify that has to do with fonts and placement and other things like that. Now here in my options, when I click on dimensions, you're going to see this area right here called offset distances. This auto placement says 15 millimeters off the part, and then each dimension has a 12 millimeter spacing between them. That is the value specifically that you're seeing right down here. Distance off the part versus subsequent spacing. So you can set that to be something pleasant. Basically window select any of your drawings with all those views and just hit auto arrange and everything will move it to those types of positions. Now in some cases, again, you want to clean that up a touch and move things around. But drawing view cleanup should all be just basic drag and drop functionality, depending on how you're trying to clean things up. One other thing that you can do with this, and I'm going to select multiple dimensions once again, is when this tool pops up, there's also a thumb wheel here at the bottom of it. And that thumb wheel actually enables me to modify the spacing that we have with each of those. For some reason, I only got one on that one. Let's do that one more time. Yeah, the other ones are going to be spaced right off the part, so they're going to be rigid on that one. Looks like we got. But when you grab those kind of things, you'll have other values that are going to then go ahead and clearly auto space. Now this is a ratio. It's going to take those initial values and it's going to go ahead and expand them up to 2 times or 3 times or 4 times those gaps. But it's another way to go ahead and make some changes relative to those. The other thing that I absolutely love about that little tool, say you go ahead and pick on a dimension, for example. When you pop this up, this is a very quick way for us to go ahead and apply things like a tolerance. Say I want to go ahead and put a bilateral tolerance on it. Maybe change those values. Bless you, all in this heads up toolbar here. And go ahead and type the word radius or 2x. All of this stuff can be done right here without having to go into the properties of this dimension. Now that said, this dimension is also one that came from the part file itself, just like this one right up here. And if we look at these side by side, you'll notice that my 55 dimension on the top is identical over here in the drawing. When you bring in the dimensions from the model, any of these changes that we make at the drawing level are also going to be bidirectional. So if I go ahead and put this thing to, once again, we'll do a bilateral tolerance and just do a little plus and minus on this. That looks pretty good. So now in my drawing, what we have is 55 plus or minus 0.1.2. When I click back over into my part window, you'll see that that's there as well. Okay? So all of these changes when you bring in these dimensions are fully associative from one view to the other. Now when it comes down to it, not all dimensions that are used to model the part are the ones that we end up using here at the 2D drawing. Basically what happens in these types of cases is that you want to supplement with additional dimensions. So for example, on something like this, I'm going to bring in some center lines, for example. So I'm just going to right click inside this view. We're going to go ahead and go to annotations, and I'm going to go ahead and bring in some center lines. Now we can do these automatically. Auto insert, select the view, they'll put them in where any cylinder happens to be. But you can also insert center lines just by picking a couple of lines. Say if I pick, right there, it does it automatically on the center as well. Can't quite get the ones I want to do over there. But by picking 2 lines ahead of time and picking center line, it will bisect those and put a center line right in the middle. The main thing I wanted to show here is that as I add additional dimensions, there's a behavior that takes place within the part and the drawing. So by adding a dimension after the fact, again, this doesn't drive the geometry, but if the part changes, this dimension will accurately update. Say I put a dimension between this hole and the center line, for example. Now what happens on this, I think I've turned rapid draft off. Let me do this again, sorry. Wanted to show you how this works. This is a setting that a lot of our users actually do turn off. I'm gonna go between a circle and a center line. Now this widget pops up. I'm sure everybody has seen it. Most of you probably ignored that just like the other thing. But what it does is it does dimensional placement based on that same distance value. I am closer cursor-wise to the top of the view than I am to the bottom of the view. So what happens is it automatically defaults to that direction. But if I hover over the bottom half of that widget, you'll notice that it will push dimensions out of the way and auto-place and space that dimension below it. So this 55 up top, well, there's plenty of room up there because we had this 22 that was right there. But if I want to put it on the bottom, I could go ahead and move that one out. Now say I go ahead and put this one in place. Once again, it's going to go ahead and automatically nest those as necessary based on what happened to get selected. So it's a pretty interesting little process there. Yes? I'm not turning anything on. It should be a default, but I'll show you where it's turned on and off here in just a sec. Yeah, so it'll be on by default, but I'll do it in this view here because obviously we just have the one dimension there. It's a little clear. It puts it to the top or it shoves this dimension out of the way to the bottom. What happens is as you put a dimension on over here in your property manager, this thing called rapid draft is something you can turn off. Now it might be off by default for you, so you're not seeing that. This came in about SOLIDWORKS 2007, 2008, somewhere in there. So it's been around for quite a while. But what does get a little different here is in a circumstance where we get into a circular feature. When I pick on an edge, now I get a quadrant instead of a line. And what it will do is it will find open space wherever it has to drop that dimension as I hover over those different quadrants. So again, it's a pretty quick placement. You can choose where it goes, and then you're basically done. So those are a couple of really cool power tools that allow us to get some of this data in there much, much quicker than before. Excuse me. Last thing I'll do on this one here is GD&T and Datums. Now, you've really got to have a handle on GD&T in order to put these things on there properly. But there are full production level tools for absolutely everything that we do up here at the top. So if it happened to be a datum feature, for example, we go ahead and grab on a face. You can drop that datum on a face. You can drop that datum directly on a dimension if necessary, which if I grab it on a linear dimension, it's actually going to put it on that value. You can put it pretty much anywhere that you'd like. Now by putting it on these additional faces, what I've now got are things that can be brought in or go to the part file depending on how we do those. But GD&T is the main part here, and that's going to be a feature control frame. So when you set up a feature control frame, it's really just about filling in the cells on this. You want to go ahead and grab the tolerance that you're looking for. So we'll do something like, let's just do parallelism. We'll do that between datums A, B, and C. Just type those in. That's pretty good. And then you can even use things like maximum or least material condition, and then some other settings in there. But you're getting a preview of everything that takes place. Some of these aren't going to matter. I just wanted to put them in there for effect. That looks pretty good. 0.055. Good. Now, my cursor now has this very rich feature control frame out on the drawing. So I can go ahead and click to insert that if I want to. I can click to drop it directly on a dimension if I want to. And there's a little different behavior on each of those. This one out there is basically on its own. You can add a leader to it or remove the leader depending on what you want to do. If you take that leader and actually drop it onto an edge, when you move it around, it will automatically snap in a direction or perpendicular to that edge. So there's a lot of very clean behaviors that are there. It even puts the nice perfect gap in between that, which is pretty crazy. See how that snaps that thing in. But when it's on a dimension, it actually lives on the dimension. You can move it around on the dimension if you want to. Usually use the shift key to get that to move a little bit. Or hold the shift key to pick and drag it off of the dimension. Or reversing, shift key to pick and drag that onto the dimension. Oh, didn't work that way. Let's just drop it on there. So there's many different ways that you can apply these feature control frames and then locate them around your 2D drawing. All right, so we're going to move over, just keeping an eye on time there. We're probably going to go just a touch long on that, but that's okay. So let's just go ahead and hit assemblies, because this is really a big part about everything that we do here. It's not just detailing an individual part, but also putting the 3D assembly file onto the drawing. Now, the 3D assembly is something that is fully available to be placed on the same file as the views of this part. You can either separate it out into its own drawing if you'd like to, or just by using some simple things here in SOLIDWORKS, we can go down in a very Excel-like way and hit New Drawing Sheet. Now, generally when you do a new drawing sheet, it's going to bring up the same drawing sheet that you used to start. And that hasn't always been the case, but around SOLIDWORKS 2016, we started doing that a lot better. But down here, once again, you're going to see the name of the file that happens to be on there, associative weight, scale, and now sheets are now 2 of 2. We go back to sheet 1, and of course that's going to read, oop, didn't read the right way. There we go. Now we have sheet 1 of 2 after a rebuild. Well, on sheet 2, what I want to do is go ahead and actually bring in a view of the assembly. Now, a couple of different ways that you can do that, but I'm going to do a very rudimentary or a very deliberate way here, is when you're sitting on the drawing and you go up to your view layout, we have a button up here called Model View. Now, I'm only using Model View right now because I have that file open in another window, and I can grab it pretty easily. Otherwise, you've got to browse for it, so you can either have it open now or open it through this command. But essentially what happens with this is you're now going to get this nice little view that we've got out here. And I like to see what that view looks like. I like to choose what kind of view that's going to be, and even the configuration that you're going to use for that particular view. So here we can go ahead and on a second sheet, go ahead and drop a view of the assembly. Now, same thing here. I generally don't like to have a small looking view of this part or assembly. So you can either pick inside that view and change the scale of the view specifically, or you can come down here to the scale tool and actually change the scale of the entire sheet. And what this will do is make that happen quite quickly. And I think I'm keeping that one separate. Let's use sheet scale. All right, so that now moves up to being an appropriate size. Now assemblies, I do a couple of different things. I typically like to show these as shaded just because the colors will give you differentiation above and beyond things like just the hatching. But you also have the capability, once in an assembly, to display this in its exploded state, which is a setting right here at the top of the view palette if you're dealing with an assembly that has an exploded view. If it doesn't for this configuration or for this view, that will simply be grayed out. But by showing this in the exploded state, this now gives us some capabilities here at the drawing level to be able to see this a little bit more easily, which we'll go ahead and zoom in a little bit on that. Now, whenever you have an assembly here, this is, again, poster child for bill of materials. So by picking inside the view of the assembly and going to annotations, you're going to see a little pull-down menu up here for tables. And there's a lot of different tables that you can add depending on the purpose. If it's a sheet metal part, you'll want a bend table or a punch table. If it's a weldment, you're going to want a weld cut list or a weld table. But for a regular assembly of just a bunch of parts created through a variety of means, we just want a quantity and a count. So if you just go ahead and insert a bill of materials to something like this, you can now go ahead and select templates. Everything that we do has the ability to be consistently set up for your process. So we'll give you these bill of materials templates, and all they are is column headings. Typically there's a quantity, a part number, a description, maybe a material, something else. All of those can be saved and tweaked for your purposes. So the next time you do this, you don't have to do all the massaging that I'm showing you. I'm going to use one here called BOM Standard, but if I hit my browse button, you'll see I've got ones for circuit boards and for my costing application, if it's a weldment, if it's a pipe layout. I use different templates because I want different columns for different purposes. But in this case right here, we're going to go ahead and just use my standard bill of materials that comes with SolidWorks. You can show it with top-level files only, all of the parts, regardless of subassembly structure, or as an indented list, which will mimic exactly the feature tree in the assembly file itself. But as parts only, it's just going to go ahead and populate this entire bill of materials based on what columns of properties are there. Now these bills are Excel spreadsheets essentially. These are SolidWorks homegrown ones, but they behave like spreadsheets. But they'll snap into place automatically. So as you're dragging it around, if I go up near the edge of my border, you'll see it actually snaps right to the border. And if you go to the right, it'll actually snap right into that corner. Now there are anchor points that you can set up so it'll be specifically in a spot. So if you like to have it actually snapped in right down here, even the bottom corners of it are snapping. But you want to snap it into that anchor point so as it grows vertically instead of growing south. In this case, I'm just going to snap it into the upper right-hand corner. Now what's really awesome about this, again, is that it takes the properties, things like the file names, the description, which is a property that we can type in for pretty much anything, and those automatically populate. But the quantities are a count-up number. So from an accuracy standpoint, if you just have the files in the assembly, the bill takes care of itself. Now, a customer I spoke to earlier today, they've got a really nifty way of putting in things that they don't model, things like lubricants or coatings or adhesives. Those are things you don't put on your models generally, but they have part files that have properties like the vendor and the cost and the coverage, and it's a blank file that they just drop into their assemblies. And that way on the bottom of your bill of materials, you're going to see things like hydraulic lube or whatever it happens to be, because it's a part file full of properties that doesn't necessarily have geometry, but it does represent something that the bill has to be spec'd out for. So those are really important things about this. I got a bunch of 4s, I got a bunch of 2s in there, everything looks good. Now ballooning is easy. You can grab the balloon tool off the annotations tab, and being very non-specific, just go ahead and start picking on a bunch of parts and adding the numbers. It doesn't matter which parts you click because this isn't a place where you can make a mistake. The numbers are indicative of what you've clicked. So here we have a number 30. If I take the arrow and drag it over to another part, it's going to simply tell us what balloon it's now pointing to. So it's really difficult to make an error in this case. Now this is also not the best way to balloon. What I would typically do is just pick the view itself and hit auto balloon. And that way any part that's physically visible will get a balloon automatically. Auto balloon lays it out with magnetic lines, and if I start to change the scaling and the size of this, you'll see that everything changes the size and scale automatically. Now that being said, these can also be moved after the fact if you want to reposition them. You'll see my magnetic lines here allow me to reposition the balloons in mass. You can change their angles and their spacings in mass, or I can simply pull it off of there and detach, and they're no longer part of the magnetic layout. But if you grab that magnetic line and start snapping balloons again, you're going to grab them up and they're going to be placed automatic spacing on the bill. Now a couple things that happen here as well is there is some talkback on this drawing. If you were to go ahead and select a part, you'll notice that that part highlights on the bill of materials. This again has been around for quite a few years, but it's just one of those things that not everybody typically looks at. If you hover over your bill of materials, you'll see a way to move it by grabbing it. You don't need to grab that necessarily. If you just hold your Alt key down, you can pick and drag it from anywhere. But you'll also see 3 arrows that pop out. And if you go ahead and click those, this will indicate what parts have balloons and what parts do not. It's a very simple graphic there, but it tells you what you have yet to do and what might be not visible. The piston, the plunger, and the core connection are inside the assembly. They couldn't be seen, therefore they didn't get ballooned out. So there's a lot of little details that you're going to see from this location. Now, associativity is a big deal for us. I got a bunch of 2s and 4s, like I said over here. If we go to this assembly and make a big change to something like this, say for example, I want to go ahead and add some stuff to it. So I'm going to grab a bunch of parts. We'll do a little bit of mirroring here just to really quickly do this. And I'm going to mirror this entire assembly to create symmetry right around the center plane. So that's good. We got files on the other side and everything is great. But what I've just done is I've also updated this file to show a different quantity. Well, now when I toggle back over to my 2D drawing, I don't have to worry about this because what's going to happen is I have new plungers, new links. I've got the new push rod and a couple of new snap links. And still mostly 2s and 4s out there. But for everything that we added quantities to, we've got updates automatically for what we've done. The one thing I don't have updates to on something like this is the exploded view. And frankly, exploded views are pretty easy because all you really got to do is just start dragging things around in the assembly. So if you edit the explode, if you want to do anything like that, you can simply grab new parts, drag them around, and then that will also update the exploded view that we've got. And I'm going to do this in a very ugly looking way, and you'll see exactly what the update looks like. So there's my exploded view updated, and we go back to the drawing and that will update there as well. So it'll be all right out in the front. So pretty cool stuff right there. This really just scratches the surface. But one of the things I want to show you down here on the bottom is the properties. You notice that says spreader on that one. This one says rod end. These properties are linked to the file itself. He's going to shut us down here in just a second. But properties-wise, one recommendation I want to give you if you want to set up properties, make yourself a file that has all the properties you want in it. I've got one here that I have called the properties seed file. You'll notice if I go to file and down to properties, what I've done is I've added things that I want to find or put in my title block. So number, description, author, bill of materials, material, and so on. The way to set up a template to have those properties in there, and again, I want to do this really quickly, is if I was to start a new file, say we'll go to a new SolidWorks drawing, and I'm going to use that same C-size template that I just started with. When you look down here in the corner, it looks virtually blank. But by right-clicking and going to Edit Sheet Format, you'll see some of the magical properties automatically show up. These are values that are going to populate based on what gets dropped in. Now, many times what a user does in these cases is they'll grab their note tool and they'll type something hard-coded. Well, the button you want to use is this one right over here. It's called Link to Property. When I click Link to Property, it's going to give me a pull-down list of all the properties that are in this file. But if you notice, there's just a bunch of whole SolidWorks files on this one. In order to get other properties from part files to be able to be filled out, you have to have that part file on the drawing. So one of the things I'll generally do in a circumstance like this is I'll take my seed part and I'll just drop it onto the 2D drawing. By having that part now resident on this 2D drawing, now I can go ahead and edit sheet format, and then when I add a note and link it to the property, what I'm now going to have is a whole bunch of other properties available. Number, description, author, material, and so on. The goal here is to simply set this up to have these properties resident within this file. So by putting those in place, throw that in there, great. So now that's going to give me a property which is basically a description. When you set these things up, put them in place, get them where you want them, then delete the part off of the drawing, okay? What that'll then do is have a property that's no longer filled out, but if you look at the sheet format, you'll see that the description is still right there waiting to be used. That said, now you take your blank 2D drawing with all your properties set up right and do a File, Save As, or Save Sheet Format, but File, Save As, and save it as a drawing template. That way the next time I start, this one's called Properties right now, the next time I want to make a brand new 2D drawing, you're going to see one here called Properties, ready to rock. So make a seed part. Doesn't have to even have geometry. Put all the properties in it and drop it on the drawing and then fill out all of your properties, because otherwise they won't be something you can latch onto a part file unless the part file is actually on the drawing to grab those. So sorry, that was a little bit rough at the end there, but I wanted to make sure you saw that one because that's a pretty essential one for creating these types of geometries. All right, we already did the changes. I'm going to leave this open to any questions now. They're not kind of shutting us down yet. Does anybody have questions, something you'd like to see, something you can't live without and you got to know about?
Where did you say you can find this video?
Say that one more time, sorry?
Where did you say you can find the video?
The videos are going to be posted on the user group site that you used to sign up on. So there's another link in there that's going to be all the downloaded videos, and they're going to be for everyone that we've had for the last 2 years or so.
So are they dated?
They will be, yep. Yeah, I'm going to throw them on a flash drive. He's going to upload them today or tomorrow. They should be up there within a day or so. Yeah, so pretty good. So again, all these processes, start with the drawing of the assembly, drop them onto your drawing, bring as much from the assembly or part as you can so you don't have to recreate the wheel, but add things where necessary. It's a pretty important part of that. But rest assured, if you change the part or change the assembly, the drawing will update. You just got to, work with it, and everything's going to flow very nicely that way. So I want to be around here for the next section as well, but if you have any questions, want to come up and ask me, I'm going to hang out here while they're having dessert. So thanks for your time today.
Yeah.